Test for cations, I did it yesterday. Test for anions, I'm going to do it today. Test for gases, I'll do it today. And the last one is the flame test, which you already done before, and we can do that later on. Okay? Alright, let's do the anion first. The first anion is carbonate, right? Carbonate. Now, in terms of carbonate, we are going to react carbonate with acid, am I correct? What does it say on the table? Test for anion. Anion meaning negative ion. Okay, negative ion means negatively charged. Carbonate, CO3 2 minus. Everyone saw it? Okay, does it say react with acid? What does it say there? What does it say on your piece of paper? Add dilute acid, kan? Did they mention pakai acid apa? No, because every single metal carbonate will react with any acid, and you will get salt because acid react to form salt, and then you will get carbon dioxide gas, and then you will get water. So I'm going to produce carbon dioxide gas, okay? So what is the test for carbon dioxide gas? Yeah, anyone? Last time I forgot who was the one who test for carbon dioxide gas. Yes, what's the test for carbon dioxide gas? Sorry? Using what? Lime water turns milky, so apa you pakai? You use lime water, right? Okay. So this is ammonium carbonate. So ammonium carbonate. I'm just going to add some acid to it. This is lime water. You can choose any acid you want. You can choose hydrochloric acid, you can choose nitric acid, or you can choose sulfuric acid. Okay. If I have hydrochloric acid, what is the name of the salt I will get? The metal, the carbonate is, let's say, sodium carbonate. Sodium carbonate plus hydrochloric acid. What is the name of the salt? Nama. What's the name of the salt? Yeah, it's a chloride, but the metal in front is sodium because I reacted sodium carbonate with hydrochloric acid. The name of the salt is, yes, what is? Sodium, well, the salt comes from hydrochloric acid, so what's the name? Hydrochloric acid give you what kind of salt? Chloride with the IDE, okay? Now, if I use sulfuric acid, what salt do I get? Yes, Adiru? If I use sulfuric acid, what salt do I get? Sorry? Sulfuric acid is what I use. What is the name of the salt? Sulfate, but the metal in front depends on what carbonate you pakai. If you use sodium carbonate, you get sodium sulfate. If you pakai calcium carbonate, you get calcium sulfate. Yeah? If I use nitric acid, what do I get? Nitrate with the ATE, okay? Now, I am going to choose, okay, choose one acid. What acid you want to use?
Nitric acid.
Nitric acid, okay? So, I should have a test tube. Can someone help me? This is lime water, yeah? It says lime water here. Lime water. What color is lime water? So lime water is a solution, colorless, okay? Can someone come and hold it for me? So it will be like this. Yeah, come. Okay, I need to go. Okay, just hold it so that you see what we are doing is I'm gonna react this and produce a gas, and when the gas gets produced, the gas is gonna go in there, and then you will see bubble. Okay, so at the moment nothing. Okay, what he said he wanted nitric acid, right? So nitric acid. So come and observe what happened. Okay, what do you see? Observe what happened in here. Okay, not much, right? The carbonate is not a lot, yeah. The carbonate is not a lot, which is why I'm going to add a lot more carbonate. Grab me a spatula, a metal spatula. Metal spatula. Okay. I think the solution is not that concentrated, so I'm going to add a lot more carbonate inside here. I want to add a lot more carbonate inside here. And at the same time, I want to add a lot more acid. I want to show you the effect of carbon dioxide. Yeah, don't worry, it's just lime water. What do you notice the lime water? I know, you see bubbles. Bubble, the gas goes through there. The gas goes in there. Last time you used a straw to bubble into lime water, right? Here the gas produces carbon dioxide, and the carbon dioxide goes into lime water. What happened to the lime water? Okay, so lime water is what you use. And then what is the result? The lime water turns milky. What is the gas present? Carbon dioxide is present. That is the gas that passed through. So what reacts with the acid to give you carbon dioxide? What is the ion? Test for ions. Ion meaning charged particle. What is the ion that is inside here that give you the carbon dioxide? It's alright, let go. Yeah, what is the test? What is the test for what ion are you testing for? You're testing for which ion? Yang reacted with acid. Just now I added acid to this. What is the ion present in here? Carbonate, because carbonate is CO3 2 minus. Carbonate reacts with any acid that contains H plus, any acid, hydrochloric or nitric or sulfuric, and then it produces carbon dioxide. Bubble carbon dioxide into lime water. The test is you cannot put lime water into here. You have to take out the gas. So you bubble the gas into lime water. This is the apparatus setup, yeah? Look, this is a glass tube. This was a test tube filled with lime water, which was a solution. That was what Nasrul held just now, right? And then I bubble the gas masuk sini, gas enter here, and reacts with the lime water and it goes milky. The gas is carbon dioxide. The observation is lime water goes milky. What ion was present? Carbonate. The formula for carbonate is CO3 2 minus. The ion present is CO3 2 minus. Happy? Okay? Carbon dioxide, okay? You might want to wash your hand, but it's just lime water, it's fine. Just wash your hand, okay? Your hand tadi kena kan? Okay, what's the next ion? Chloride. Okay? Chloride, bromide, iodide. You did it when we did group 7 chemistry. So chloride, bromide, iodide, I'm going to do them 3 in one go because they are going to be similar, okay? Now, test for chloride, bromide, iodide. I think I need 1 nitric acid. Can you bring me some more nitric acid? I ran out of nitric acid. You see the instruction there? Add nitric acid, am I correct? Yes. So, nitric acid, find nitric acid. Okay, so I've got to add nitric acid to all 3 of them. I have sodium chloride. I have sodium chloride. I have potassium bromide. And I have potassium iodide. Now that's silver nitrate. I need nitric acid. Nitric acid. Okay, what color are these solutions? So they are colorless. Are they solution or precipitate? Solution. Because they are all see through their solution. Okay, so we have chloride. There should be nitric acid. You know how to find nitric acid? Nitric. It says nitric acid on the label. It should have a nitric acid on the label. Nitric, N-I-T-R-I-C. Okay. Now, 3 of these are colorless. You don't know which one is which one, right? Well, actually you know because chloride, bromide, iodide in that order, okay? So, watch what happens when I add nitric acid. Anything? No. Nothing, okay? There's meant to be nothing happening, okay? Because you haven't added in the second reagent. Adding nitric acid will not do anything, but you must add nitric acid to all 3 of them. Test for chloride, Cl minus, bromide, Br minus, iodide, I minus, add nitric acid. After you add nitric acid, what do you add? Okay, find for me silver nitrate in the, no, here. Come, find for me the silver nitrate. You got silver nitrate? Okay, go on, do it. Okay, hold the test tube, and then start adding, okay? Just add, and then you will know. Make sure people can see what you are doing. You just hold the top of the test tube. Yeah, it's fine. You won't see it, okay? Just take it out and take it, okay? Put a few drops, okay? Hold the top so that people can see what you're doing. Hold the top and then show it, okay? Alright. Okay, just add. Hold it high and everyone see what happened. What do you see? Okay? Yep, keep on dropping just for the whole lot. Yep, and then shake it. Yep. Yeah, just add the whole thing, it's fine. Okay, and then shake. Now, shake like this. Okay, what do you get? So this was chloride. What was the first thing you added? You added nitric acid first, then you add silver nitrate. Silver nitrate that she added, was it solid or solution that she added? Did she add, when she put in the drops, was it solid or solution? Solution. Okay, So what happened now? You get a solid precipitate. This reaction is called precipitation, just like yesterday, because solutions and solutions give you, what is this now? What do you call this? White precipitate. That was chloride, yeah, okay? But Zakira, come and do the second one. So this one, I already added nitric acid, right? So she just need to add the silver nitrate. Yeah, come. Just add. It's fine, just add. Trust me, okay? Let people see the observation, okay? It's fine, you won't see it. Just take out and just add, okay? Let people see the observation. Okay? Shake it. Do you notice that it's a bit macam no longer white? Yeah, it's more yellowy now, but you don't call this yellow. You call this cream because later on we're gonna do the iodide and then it will be even more yellow, okay? Alright, come Saiful, come and do it. So I already added, what was the first thing I added just now? No, you are going to add silver nitrate, but before that I already added something. What was it I added already? Test for chloride, bromide, iodide. I already added something just now. What did I add? No, iodide is what I want to test for. What did I add just now? Nitric acid. I added nitric acid. Come on, add the silver nitrate now. So silver nitrate is the solution, okay? So see what Saiful got, okay? Yeah, keep on adding. Shake it. Keep on adding more. Okay, add some more. So again, just pour. Just pour. Just pour from the bottom. Okay, alright, thank you. Alright, this is more yellowy. So in that order, it was on the left, it was chloride, precipitate out as silver chloride because you have added nitric acid and then you have added silver nitrate. So now what you get is silver chloride. What is the observation? White precipitate. These two are quite hard to see. Usually it is easier to see. Let me borrow your white paper. See the difference? Very slightly. One is more yellowy than the other, right? Yeah, okay. But like this is quite hard to tell the difference, but like this is much better, okay? Which one is more yellow? Right or left? Right hand side. The one which is more yellow is the test for iodide. The one that gives you yellow precipitate, and then the other one which is more cream. So it's not white because white, cream, yellow. Precipitate, test for chloride, test for bromide, test for iodide. What you see is you see a yellow precipitate, but what does it tell you? What is the conclusion? The ion present is iodide, I minus, iodide, stated in the table. Am I correct? Yeah, okay. What's the next test? Sulfate, that's the last one, right? Okay, sulfate. Let me try and find my sulfate. Okay, I'm left with very little sulfate. This is ammonium sulfate, NH4 plus from yesterday, NH4 plus, sulfate, SO42 minus. The crisscross, year 9, chemical formula. Year 9 before the home-based learning. If you don't know, maybe you should go home and do your work, the real work, okay? And that goes to most of you as well. Ammonium sulfate, yeah? So the solutions, if you see the test there, is solution, right? Aqueous, right? Aqueous means solution. Solution, kan? Sulfate, right? Okay. What's the first thing I do? But Iqbal, come, Iqbal, come. Right, what should Iqbal add first? Nah, nitric acid. So Iqbal is going to add nitric acid. Just do one hand. Okay? Anything happening? Okay, got you. Anything happening? Nothing. Because it's just like before, you just add nitric acid because you don't want there to be carbonate. There's no effervescence, kan? Not a bubble, kan? So no carbonate, okay? Now after that, barium nitrate. Barium nitrate. Tuna. Aqueous barium nitrate. What color is it? Is it solution or solid? Solution, okay? Nah, there you go. Tambah. So just add a few drops. Okay. No, go. Make sure the camera catches you in action. Ah, you missed it.
Sorry.
You got it? Everyone see what happened? Okay, shake it. Shake it harder. Okay, what do you see? Is that the observation there? So, kalau you ada tambah barium nitrate, if there is a reagent yang ada barium nitrate atau barium chloride, and you get a white precipitate, what does it tell you? What is the ion yang present? What is the test for? No, what is the test for? Sulfate. Make sure you can spell and pronounce properly. ATE, sulfate. SO42 minus, sulfate comes from sulfuric acid. Do you remember sulfuric acid?
Yes.
What's the formula for sulfuric acid? What's the formula for sulfuric acid? No, sulfuric acid ada SO42 minus. Acid ada H plus. H plus, SO42 minus. You need 2 of the H plus. So it's called H2SO4. Okay? Is that all the anions done?
Yes.
Cation yesterday already. Okay, what's the next page? Test for gas, am I correct? What's the first gas? Okay, remember the smell of ammonia?
Yes.
What does it smell like? You know, how do you don't say that like, you know, you call it pungent, okay? Where was my ammonium sulfate just now? Yeah, my ammonium sulfate is ready. Where was my ammonium? Okay, but do you remember the test for ammonium from yesterday?
Yes.
I really don't have enough ammonium, so I don't get to show you ammonium. But remember the test yesterday was, you need to use a moist red litmus paper, and then what happened to it? The red litmus paper turns blue, the gas is NH3 atau ammonia. Okay, you remember the smell, right? You don't need to smell it again, right? Okay, everyone remember it? Okay. Now remember the observation as well, yeah? What's the second gas? Carbon dioxide. You just did it. Remember just now the carbonate plus the acid, and then who was it just now? Tuna. You get the white precipitate settled down at the bottom already. You have the white solid, lime water turns milky, kan? Okay? That was the observation just now, the first one. Carbonate plus acid give you carbon dioxide. What is the test for carbon dioxide? It turns lime water milky. That was what Nazrul helped me with. Remember? Okay? Now what was the next one? Chlorine gas. Okay, chlorine I'll do much later. Skip that one first. What's the next one? Okay. How do you get hydrogen in the lab? There are 2 reactions that can produce hydrogen in the lab. One is metal plus water. That was under alkali metal topic. Metal plus water. Metal hydroxide. Maybe you can write down. Metal plus water give you metal hydroxide plus hydrogen. Okay. Metal you write down. Okay. Metal plus hydrogen give you metal hydroxide plus hydrogen. That was in the alkali metal topic, yeah? Metal plus hydrogen. As a metal plus water. Metal plus water give you really don't want to write in the table. Write at the bottom, guys. Don't write inside the table. Okay, what does metal plus water give you?
Metal hydroxide.
Metal hydroxide and hydrogen gas. There is hydrogen gas also. Okay. But I'm not going to do metal plus water. I will do the easier one. Metal plus acid. That's the second one. Metal plus acid give you hydroxide plus hydrogen. Everyone get the first one? The first one was metal plus water. Hydroxide plus hydrogen gas. It is the second one that I'm going to show you. Metal plus acid. Acid react to give you metal salt, and you will get hydrogen gas as well. Okay? So metal plus acid also gives you hydrogen gas, and that is what we are going to do here. Alright, when you're ready, come back here. So what I have is magnesium metal. This is the empty test tube. So I'm just going to put some magnesium powder into it. So that is magnesium. So that's the color of magnesium. What color do you see?
Black.
It's kind of gray. It's kind of gray, yeah? It's solid, do you agree? It's solid, yeah? Metal is solid, okay? Pass it around. Magnesium, okay? The metal is magnesium. The metal is magnesium. What acid do you want to use? Give me one acid, yes? Yeah, let's try, sorry? Hydrochloric, okay. Okay, magnesium plus hydrochloric acid. You ask about hydrochloric acid, what is the name of the salt? Metal, sorry? Magnesium metal plus hydrochloric acid. So you get a metal salt and you get hydrogen gas. What's the name of the metal salt? Magnesium chloride is correct because the acid used is hydrochloric acid. Okay, come and observe what happened. I better get this ready first. Yeah? Where's my lighter? I asked for a lighter just now. And then I can use match. But grab a lighter also. The match always doesn't work. Okay. It's fine. It's fine. It works now. Okay. All right. Okay. Ready? Yeah. Don't smell it. It's not very good for your lung. Okay. Where was it? Oh yeah, magnesium is here. Someone want to do this? Who wants to do it? Yes, Hadiru, come. Okay, so on one hand you hold this. Why do I need a wooden splitter? Because I'm going to test for the gas, right? Test for hydrogen, what do I use?
Test for hydrogen.
Gas. Do I use, what do you call this?
Burning split.
Okay. What do you call this?
Glowing.
Which one do you use?
Glowing.
Glowing? Okay, but try, but add some acid. Okay, but I don't know, you do yourself, multitask. There's no gas, right? You must react them together first, right?
Campur kah?
I don't know, the reaction is going to happen on its own. Okay, observe what happened. What do you see? What do you see?
White split.
Really? Show it to them. What do you guys see? What do you see? No. What do you see?
White split.
No, I know. What do you hear?
Sound.
Why are they sound? Because, can you see the bubble?
Yeah.
So what did you say? You say white precipitate. There's bubble, there's gas there, okay? Hold it tight, close it so that you are collecting the gas, okay? Okay, one hand ready with that. Okay. This is actually not good. Okay. Never mind. Okay, alright, test for the gas. You're left-handed, right? Okay. Okay. I don't know which one. Which one you mau pakai? Masukkan lah. Anything?
No.
So it's not the one you used, that is the other one then. What is the other one?
Burning split.
I don't know, try lah. So which one is correct then? What is the proper test for hydrogen gas?
Burning split.
Oh, okay, I thought you said glowing splint just now. So what is the test for hydrogen gas? Lighted splint, or you can say burning splint. They mean the same thing. Lighted splint means still has the flame going on, okay? So, but what happened to the fire just now? What happened to the fire? Did it continue burning?
No.
Because hydrogen reacts with oxygen. What do you get? Okay, the pop sign is not that noticeable anymore, but the fire goes out, right? When hydrogen reacts with oxygen, what do you get? Hydrogen, H2. Oxygen, O2. H2 and O2 combine together, what do you get? Hydrogen plus oxygen, what do you get? It's the most basic, sorry? No, you get a molecule. 2 hydrogen, 1 oxygen, lower secondary from 1 science. You drink it every day. H2O. Yeah, which is water. Do you use water to put out fire? There was fire and water is being formed as the hydrogen reacts. Can water support burning? Will it continue burning if you produce water? No, the fire will go out. Agree? Okay, test for hydrogen, okay? Now you're gonna test for oxygen, okay? Someone gonna try test for oxygen? Okay, Shafika, come. Come. Alright? Now, Shafika is going to produce oxygen. This is hydrogen peroxide. You can get it, careful with the fire, yeah? You can get it from Guardian or anywhere also. See, we don't need the fire. Okay, so as you can see, there are no bubbles or anything, right? Okay, naturally, hydrogen peroxide will decompose. It will turn into water by releasing oxygen gas. But I can make it faster. I can use a catalyst. What does a catalyst do? What does a catalyst do in a reaction? The word catalyst, C-A-T-A-L-Y-S-T. What does a catalyst do? Don't know? What does a catalyst do? The English word is catalyst. The verb is called catalyze. What does catalyze mean? No one knows the English word. Catalyst, catalyze. We did it under rate of reaction. Rate means kelajuan. So what does a catalyst do? We need young people, young and educated and skilled people to catalyze the growth of Brunei. Sorry, say that again. Speed up. What does speed up mean? Does it make the reaction faster or slower?
Faster.
So what is the use of catalyst then? To what? To speed up reaction. Another word for it is to make the reaction go faster. These are all in the rate of reaction, guys. There was a few months ago, yeah, and it was face to face, okay? Anyway, this is a compound which I can add and it will speed up the rate of these reactions. Okay, what do you see now? What do you see now?
Bubble.
Can you hear it?
Yes.
Can you hear it?
Yes.
Of course, you see first. Do you see the bubbles? Okay, do you see the bubbles? You guys see the bubbles? Okay, come closer and hear it. Yeah, anyone else? Anyone else haven't seen? I know it's disgusting, but the black solid is a catalyst. It's a catalyst used up in a reaction. Catalysts speed up the rate of reaction. Do you use up the catalyst at all? Hello everyone. Do you use up catalyst? Does catalyst react? No. It only speed up reaction. If it doesn't react, is it used up? Kena guna pakai? It doesn't react. Kena guna pakai? So will you get the exact same amount as what you started with? Yes, because it only makes your reaction go faster. You see the bubble?
Yes.
I think the reaction is finished. It's quite fast, yeah? And I'm going to add some more peroxide. Catalyst, how do you spell the word catalyst?
C-A-T-A-L-Y-S.
Come, you can probably hear it now. You can see the bubbles, right? Can you hear it?
Yes.
Ah, crack. Okay, alright, come. Siapa tadi? Ah. So the oxygen gas is continuously being produced. How do you test for oxygen gas? Glowing or burning spleen? I don't know. You try that. You try. Okay, come and see what she's doing. So she's producing oxygen gas. No, it's not coming. Okay. Any pop sound?
Yes.
Ada pop sound?
Ada.
Tapi the fire goes out kah?
Tidak.
No, so bukan hydrogen, okay? So now tinggal the sisa-sisa, okay? Try. Put it in. Do you see that? No, it's a different, no, come closer. Do you see the fire continue burning?
Yes.
So she put the one which was glowing or burning just now? She put glowing or burning in? Just burning. She put burning. Okay, this is burning or glowing? Glowing. Okay, I think the oxygen is running out, okay? But we can try again. Let me add some more peroxide. Okay, so burning or glowing? Which one is the test for oxygen gas?
Glowing.
Glowing, okay, try again. So she's going to say that oxygen support combustion. Hang on. Glowing, not burning. Glowing, not burning. This one is fire. Okay. Yeah, tekan ada air, then no more gas. Do you see that? Okay, so it's trying to relight. Do you see that? So what do you see? What happened to the glowing spleen just now? It relights. Relights because it goes from no flame to having flame. What was the gas present, Daniel? What was the gas that she tested for? Okay, never mind. Okay, let me ask. Shazwani, what is the gas that she tested for? Oxygen gas. Okay, thank you for listening. Okay, so oxygen gas using glowing spleens. What did you see? Did you see it? Did you see it? Did anyone not see it? Did you see it? What was the test for? Test for what gas? Oxygen is diatomic. Oxygen is diatomic. What does diatomic mean to you? O2, right? O2. Okay, what does diatomic means to you? Need to complete the sentence. What are the two atoms doing? How are they combined together? Non-metal and non-metal. What kind of bond do they form? Oxygen, non-metal. Oxygen, non-metal. What kind of bond do they form? So there are two atoms, they are bonded together by covalent bond. Combined together by covalent bond, okay? This looks disgusting, but I can essentially, okay, how can I separate the solution from the black solid? So the catalyst is the black solid. Is it soluble? No. But I want the solution. How can I separate the black solid from the solution? The solution is the cair, yeah? It's the solution, okay? But they are solid. The black solid, right? Insoluble. How can I separate it? Azira, come, Azira. How do I get the black solid from the solution? Are you going to pick up one by one? Okay, do it for me. Pick up one by one. I thought you said you're going to pick up one by one. She said it, right? So how are you going to give me the black solid? Tell me, how are you going to give me the black solid? Any idea?
Filtration.
Sorry?
Filtration.
Okay, why does, hello? Listen that? Why does filtration work? So, what apparatus do you need for filtration? Go and grab me the apparatus for filtration. So we will see as she pick her choices, huh? Filtrations. So maybe she doesn't know. Do you guys see the apparatus already? Do you guys see the apparatus for filtration? It's okay, Daniel just one. Go and help her. Yeah, go and help her. No, don't help him. Go and help her. Yes, Azira, mana? Daniel just one, mana? I know, show me. This is your lab, right? Go and take it. What do you call that? What is that apparatus called? Oh, sorry to say, this lesson is recorded. It will go on to, YouTube. Oh, wait. What is that apparatus that he picked up called? Filter funnel. It's an English word, funnel. Okay. Now, I pause straight away.
No.
What do I need?
Another
Go and take apparatus from me, someone. Hey. Go and take apparatus. What do you want? Okay. Who said beaker just now? Go and take that. Okay. I don't know. Beaker, right? She said beaker. Okay. Is that all the gas ready? Hydrogen, oxygen, carbon dioxide, ammonia, tinggal chlorine, right? Okay. All right. Okay. Show me. How? No, show me. Tell me that. How? You were the one who say, right? So, how? No, beaker is not a good choice. Beaker is never a good choice. Test tube is not a good choice. Heavy, light. There's another apparatus there. Get me the conical flask. Someone get me a conical flask. But Nazrul, go and get me the conical flask. This one, the problem is, you see the problem? In engineering, there's already a problem. Light, heavy. Beaker, what is the problem? It's going to always fall on one side, right? Problem solved. See that? Oh, now what do? I pour. Pour? I pour? What's the problem about it? Oh, filter paper. But go and find for me filter paper. Just have filter paper there. Go. Filter paper is somewhere there. Go and find filter paper. Whoever said I should pour the roast, maybe you should think. Next time you drink coffee, and then the filter coffee is not filtered at all. I don't think you can work in coffee shop. Okay, show me how to prepare the filter paper. How do you prepare filter paper for filtration? What do you need to do? Sorry, tell me. Tell the camera, what are you doing? What are you doing? Fold. How do you fold it? Fold it into? Fold it into half because you're halving it, okay? And then? What is the second step you're doing? Fold it again into half, okay? And then? Fold first. You said it right, fold first. And then you open it up, okay? Alright, and then what next? I don't know, show me. Later people are gonna say, this teacher doesn't teach anything. Students aja yang buat. I don't do, yeah? What next? Someone should come and help here.
Apa dia?
How?
Iya.
How?
Jawab.
Come on. Help him now. You guys also don't know how? Nah, she's gonna help you, but come and help him. No, look. And then, Badu. Now put. Badu. What next? Badu. Yeah. Oh. So, where is the black solid going to remain?
Filter paper.
Okay. What is the solid on the filter paper called? I know it's precipitate. I know it's the solid. What do you call it? A special name given for it? Solid that is left behind. Yeah, Paul. Residue, because the English word. Okay, enough. Residue. The English word is residue. Do you see the clear liquid coming through?
Yes.
What color is the liquid coming through? So what do you call the liquid that is coming through? I know, there's a special name for it. Describe the solution that comes through in the filtration technique. Residue is left behind. Residue is the solid that's left behind. What is the liquid that passed through?
Solvent.
Huh? Solid?
Solvent.
Solvent? No, it's no longer called solvent. It's called filtrate. Filtrate. Was this in year 9? Filtrate, the solution that passed through. Residue, the solid that's left behind. Year 9 separation technique. Okay. Now the very last gas is chlorine. Am I correct?
Yes.
Now before you do chlorine, start the Bunsen burner for me. Start the Bunsen burner.
Tahu lah.
Okay. Who doesn't know how to start Bunsen burner? So everyone knows how to start Bunsen burner? Wow. Let me just burn my face. So we're going to do flame test first, yeah? Remember there are three ions that you need to test for right at the bottom. What are the 3 cations? Not the metal, yeah, but the cation, okay? Now Zakira, you hold sodium. But Michelle, come. Michelle, okay? Yours is lithium, okay? Don't worry, the labels are lot, okay? Michelle is holding lithium, okay? And someone is holding potassium, but potassium. Okay, which one should we do first? Lithium first, okay, but lithium dulu. You hold lithium, yeah? Okay? No, okay. This is called flame test. How do you do flame test? First of all, can you use, crap. Can I get another lighter? Chlorine might not be some part today, yeah? But do you know the smell of Clorox?
Yes.
That is the smell of chlorine. Okay, what I'm trying to do is, can we do flame test using this flame?
No.
Because here you can see the orange color, right? What if your stuff is orange color? Then you cannot see. That's why we have to use the. This one is like not enough oxygen. That's why if I put paper on top, you will get black stuff because not enough oxygen, electrical oxygen. So to have enough oxygen, you open the air hole. You know this is the air hole. Enough oxygen comes in. Enough oxygen. Complete combustion. What does complete combustion give you? You are burning fossil fuel. Complete combustion, enough oxygen. That's why it's burning with a blue color kind of flame. Give you carbon dioxide, yeah? Carbon dioxide. Okay, and water. Who is the lithium? Lithium. Come. So blue flame. Okay, lithium ion. The N has got lithium on it. Okay, lithium plus. Have a look on the color. Yeah, just put it on top of the blue flame. Okay. Everyone try and see the color. Yours is lithium. I'm going to turn off the aircon for a bit. You see the red color?
Yes.
Is it quite clear? Oh yeah, people can see the red color now, right? Don't burn the wood, don't burn the wood. When it starts to burn, just flick it the other way around. Do you see the red color? Okay, this is the color of Li plus. Li plus. Understand that? What color was that? Li plus. Now, what solution? What color was the solution? The solution is colorless. The thing is, colorless solutions, you are not doing the color of the solution, you are doing flame test. So that is your red color, flame test, the red color. Li plus, flame test is red color. Who's the next one? What is below lithium? Sodium, but come sodium. You're next. Oh, what color is sodium? Was that from the Bunsen burner? No, right? Because we already started with blue flame, right? What color is this? Yellow. Okay, can you see the color? That's why we don't start. That's why we don't start from the flame yang not enough oxygen just now, because otherwise we cannot tell the difference. We must start from the blue color flame with enough oxygen. Blue color flame, then you put the wooden spoon that has been immersed. Rendam ya, immersed in there. Oh. But okay. Alright, so what color was Na plus again? Yellow. Bukan the solution. What color is the solution? Colorless. That's why we cannot see the thing. We have to use that. Tiga are colorless. All three are colorless solution. How do you know which one is present? Flame test. It's stated there, right? F-L-A-M-E. Flame. Pakai api. Flame test. Test of what? Test of the cation. Last one. K plus, yeah? What do you notice? Come closer. This one is quite hard to see, yeah? It's okay. Just keep on going. Just keep on going. You see the slightly different color? So just now was kind of blue, right? Now it's kind of violet. It's not a violet pulang. Lilac. We don't call it purple, yeah? Purple is really dark purple. This one is more lilac, yeah? Okay? I think it's starting to burn already. You might need to rendam semula. Starting to burn already. Okay? Now, chemistry of firework. Bunga api, yeah? Firework are colored because that's what they're doing. When you burn the firework, when it goes out to the sky, high temperature, it's burning the metal ions. Different metal ions have different color, okay? Then, you know what's the important question? What if you mix all three together? Come, give me one stick, just give me one stick. Mixture of color, right? I don't know which one is that one. I also don't know which one is that one. Can you give me one? What's the other one? Oh no, yeah, there's the wrong one. Okay, what if you have the three color mixed together? Not that strong, right? I actually have the pure science student. You see the slightly different color now? There's some red color. There's some red color. There's some lilac as well on the other side. Okay. There are some other cool ones, yeah, which you don't learn. Okay. There are some cool ones. Okay. This is one of the coolest color you can see, but this one is not in your syllabus. The pure science student, they learn this. Okay. Do you see it? Do you see it? Unfortunately, it's not in your syllabus. Do you see it?
Yes.
Do you see it? So these two are not in the syllabus, yeah? You don't have. I know, okay? This one is I forgot already. Oh, this one is this one. Yeah, this one is this one. Okay. Alright, that's it for today. We are finished with this topic. Chlorine, just stop recording.